Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 6, Lesson 9 on percent increase and percent decrease. In the last unit, we saw and reviewed how to find a percent of a certain number by just multiplying by the decimal version of that percent. Today what we want to get to and what we want to review, because this should have been something that you saw back in 8th grade math, was how we can find out where a value ends up after it's been either increased by a certain percentage or decreased by a certain percentage. So let's get right into it right away and look at the percent increase case. Percent increase. In the last lesson, as I mentioned, we saw how to find a certain percentage of a number by multiplying by a decimal. Here we want to see how to increase a quantity by a certain percentage using a single product. So let's take a look at something with beetles. Exercise number 1. Agronomists, that's just a fancy word for people who are into agriculture. Agronomists are studying how quickly the population of an invasive species of beetle will increase in a controlled farm setting. They calculate that the population is increasing at a steady rate of 6% per week. At the beginning of the week, the population was 350 beetles. Letter A, find the population of beetles a week later by first finding 6% of 350 and adding it to the original population. Okay, awesome. So this should be easy enough. I want you to figure out what 6% of 350 is. Once you find that number, I want you to then add it to the 350 to figure out what the population is a week later. Pause the video now. All right, so first things first, right? I would want to find 6% of 350, and that's going to be 0.06 times 350. It's quite all right to use our calculator for that. All right, let me bring this thing out. Let me kind of clear this out. Yeah, might as well do a new document, new calculator. I want 0.06 times 350, and that's going to give me 21. All right, so our new population is very simple. It's 350 plus 21, or 371. All right, now there's nothing wrong with that at all, but I would really like to get from 350 down to 371 using only one calculation instead of two. And in our next lesson, we'll see why that is so critically important. But let's take a look at letter B. Find the population of beetles a week later by a single multiplication. Why does this work? All right, so let's take a look at what's really going on to figure out what that single product will be, right? What we really did to find our population in the second week is we took our 350 and add to it 0.06, not 0.05, let's try that again, Kirk, 0.06 times 350. All right, so that's really the calculation we did in letter A. Now, how can we really do this as a single calculation? Well, I'm going to just be very suggestive right now and put a 1 times 350 in front of that. Now, please note, that's not a 1,350. That's supposed to be a 1 times 350. Notice now what I have is I've got a factor of 350 in each one of those things. So I'm going to factor it out, right? I'm going to take that 350 and factor it out like I've done before, and that leaves me with a 1 plus 0.06. All right, and obviously 1 plus 0.06 is just 1.06. So I claim that I can increase the number 350 using just one product, and that's the product with the number 1.06. Let's take a look, right? So instead of doing 360 times 0.06 and et cetera, I'm going to do 350 times 1.06, and there's that 371. And the reason that that works, right, is because by multiplying 350 by 1 plus 0.06, we're both getting the original 350, that's the times 1, plus we're getting the 350 times the 0.06. But we get it all by multiplying by 1.06. All right, and that's really nice because now let's take a look at letter C. What will be the beetle population after 2 weeks? Round appropriately, right? So, I mean, we could do the same thing. We could take 371 and we could multiply it by 0.06, get an answer, and then add that to 371. But let me just finish this and write down 371 there. But now we can do it much faster by just taking 371 and multiplying it by 1.06. All right? And when I do that, 371 times 1.06, we get 393.26. We can't have 0.26 of a beetle, so rounding appropriately, we have 393. All right? Very important that we're able to do this in a single calculation as opposed to two calculations, i.e. the first one multiplying by the 0.06 and the second one adding it on. Now we're getting it all. And in fact, if you think about it, we're getting 106% of what we started with. We're getting 100% of what we started with. That's the 371 plus an extra 6% of what we started with. And that gets us up to 393. This is such an amazingly important idea, right? To increase a quantity by p%, you simply need to multiply the original quantity by 1 plus p over 100. And again, that p over 100 is that decimal version of the percent that we've been working with so far. Boy, this is simple, right? Let's take a look at exercise number 2. Find the result of each of the following. Many of your answers will involve decimals. Do not round. So in other words, letter A, increase 440 by 12%. If I want to increase 440 by 12%, what I'm going to do is I'm going to multiply it by 1 plus 12 over 100, right? Now, I don't need to necessarily write this thing out, as long as I understand that that's the same as 1.12, right? I want to multiply 440 by 1.12, and that will increase it by 12%. And of course, that's simple to do, right? 1.12 times 440 gives me 492.8. Whoops, I lost that. 492.8. Percentages often involve decimals and often are a little bit messy. That's okay. Let's have you do letter B and letter C on your own, and then we'll come back and take a look at them. Now again, I'm going to keep emphasizing this first calculation, this 1 plus stuff here. You don't necessarily need to do that, but in case you're wondering, oh, well, what should I be multiplying it by, right? So in letter B, I want to increase 68 by 8%. If you're comfortable that that's 1.08, great. The idea, though, is, again, I'm multiplying it by 1 plus 8 100ths, right? So that's going to be 1.08 times 68. Awesome. Simple enough. 1.08 times 68 gives me 73.44. And again, we talked about this in our last lesson. Very often percents will involve decimals or fractions. So I want to increase 120 by 3.5%. All right, I'm going to go right for it now. That's going to be 1.035 times 120. And that's simple enough, 124.2. All right, it is very, very important. Very, very important that you understand this, that you understand how it works, because we're going to be constantly having to increase quantities by a certain percent. All right, now, there are many times when we will encounter percent increase problems in real-world scenarios. One of the places where it comes up a lot is what's called interest on a savings account, okay? So in other words, if you take money and you put it into a bank, strangely enough, for just leaving the money in a savings account in a bank, they will pay you to leave it there. By the way, the reason that they do that is because they take your money and they actually loan it to somebody else who uses it for some reason, then pays it back to them based on a certain percent that they get charged. Then they give you, the bank gives you, a small cut of that. Anyway, whatever, it's banking. So exercise number 3. Adriana has a savings account that promises to increase her balance by 2.5% per year. If she deposits $720 in it at the beginning of the year, which of the following would be her balance at the end of the year if she does not withdraw or deposit any additional money? All right, so in other words, I want to increase $720 by 2.5%, and I want you to do it with a single calculation. Pause the video now and go ahead and do that. All right, simple enough, right? I'm going to just take my 720. I'm going to multiply it by 1.025. Remember, it doesn't really matter which way that multiplication is written. So 720 times 1.025. I think it's about time to clear this thing out a little bit. 720 times 1.025, 2.5%, gives me 738. Choice 3. All right. Think about like how much more time that would have taken us. Like go all the way back with percentages. Can you imagine if you had to set up a ratio, solve the ratio to come up with what 2.5% of 720 is, then you'd take that and you'd add it to 720. Finally, you'd get 738. That'd just be obnoxious. All right. Now, we also have to work with percent decrease, all right, which is trickier than percent increase. It still follows a similar pattern, okay? So let's take a look at exercise number 4. A cup of coffee is put into a freezer that is kept at a steady 0 degrees Celsius, right? That's the freezing point of water. The coffee cools down such that its temperature in Celsius is decreasing at a constant rate of 8% per minute. The coffee starts at a temperature of 90 degrees Celsius. Letter A, find its temperature after 1 minute by finding 8% of 90 and then subtracting. Okay, so we're going to play this exactly the way we played exercise 1. In other words, I'm going to first find out what the 8% of the 90 is, and then because the temperature is going down, I'm going to subtract that off from the 90. Pause the video now and figure out what the temperature of the coffee is after 1 minute. Okay, let's do it. First things first, I'm going to find 8% of 90, and of course that's just going to be 0.08 times 90. All right, that's 7.2. That I can do, 7.2 degrees Celsius. Now I'm going to take my 90 and I'm going to subtract off my 7.2. That would be 82.8 degrees Celsius. Sorry, just trying to do a little bit of math in my head. Always dangerous, always dangerous. All right, so my final temperature after 1 minute is 82.8 degrees Celsius. And I did that the straightforward way. I found out what 8% of 90 was, 7.2 degrees Celsius. And then I just subtracted it off from the 90 because the temperature is decreasing. But just like with percent increase, what I want to do is I want to figure out how to do this with a single product. So let's take a look at letter B. Find its temperature after 1 minute by using a single product. How can you interpret this in terms of the 8%? Okay, so again, just like before, let's take a look at the actual calculation. What I really did is I took my 90 degrees and I subtracted off 0.08 times 90. Now, like before, what I'm going to do is I'm going to think about that 90 as 1 times 90. Okay, so very identical to what I did before. I've got 1 times 90 and 0.08 times 90. So I'm going to factor that 90 out, and I'm going to be left with 1 minus 0.08. Now, you might need to do the 1 minus 0.08 on your calculator. I don't, but I'm going to do it anyway because I just want to illustrate something. All right, 1 minus 0.08 is 0.92. Right, 0.92. We'll come back to that exact number in just a little bit. But basically, right, this tells me that I could have found my answer by multiplying by 0.92. Wow, that's weird. I could have found my answer by multiplying by 0.92 right from the beginning. In fact, let's verify that, right? My actual answer right after a minute was 82.8 degrees Celsius, right? I did that the old-fashioned way, but now if I multiply 90 by 0.92, and I have it show up on the screen, there's my 82.8. Now, one thing I want to talk about is the second part. How can you interpret this in terms of the original 8%, right? Well, think about it. If I take a temperature, or anything, and I reduce it by 8%, what percent of it remains? Well, 92% of it remains, right? Remember the increase. When I increased by 6%, at the end, I had sort of 1.06. I had 106%. Here, I decrease by 8%, and I have 92% remaining. So really, what I'm multiplying by is always the decimal version of the percent I have after I've done the multiplication. So if I decrease by 8%, I have 92% remaining. All right, it's always about the percent that is remaining of what you have originally. Now, if you're increasing, the percent that you have remaining is larger. And if you're decreasing, the percent that you have remaining is smaller than the original, right? Let's take a look at letter C. What will the temperature of the coffee be after 2 minutes round to the nearest degree? Well, now it's easy, right? So now I can take my 82.8 degrees, right? My 82.8, and I can multiply it by 0.92. I don't need to multiply it by 0.08, get an answer, subtract it from 82.8. I can just do 82.8 times 0.92. After a second minute, I'm only going to have 92% left of what I had after 1 minute. And again, this is easy as just punching buttons on your calculator. 82.8 times 0.92 gives me 76.176, rounded to the nearest degree. That's 76 degrees Celsius. All right, that's it. Right? Percent decrease and percent increase. Now, let's make sure that we have this, right? Decreasing a quantity by a certain percentage is trickier because you really need to think about what percent remains after you've decreased the quantity. And I was kind of harping on that last time. Let's do one more percent decrease problem real quick, and then we'll kind of summarize it all. Exercise number 5. The enrollment of students at a school is decreasing by a constant rate of 5% per year. All right, this is simple. Letter A, what percent remains after 1 year? Well, if we start with 100%, right, and we subtract 5%, then 95% remains. All right, letter B, if the population this year is 2,300, what will its population be next year, doing a single calculation? Well, again, the whole idea now is I'm going to take 2,300 and I'm going to multiply it by the decimal version of 95%, which is 0.95, right? So I simply have 2,300 times 0.95, and that will be 2,185. How fast is that? But again, the tricky thing is that understanding, well, if I decrease by 2%, I'll have 98% left, so I'm going to multiply by 0.98. If I decrease by 20%, I'm going to have 80% left, so I multiply by 0.80, or just by 0.8. Let's see if you've got this, right? Here it is. Just like with the percent increase, right? The only difference is instead of 1 plus p over 100, it's 1 minus p over 100. It's really quite simple, and that will result in 100% minus p% of the quantity left. So let's take a look at exercise number 6. Find the result of each of the following. Many of your answers will involve decimals. Do not round. Write the calculations you use to find your answers. Okay, so decrease 620 by 15%. There's a lot of different ways that you could go about doing this. One way is just to say, well, okay, I've got 100% minus 15% is going to be 85%, right? And now I need to find 85% of 620. So I can just do 620 times 0.85. There I'll have to use my calculator. 620 times 0.85, and I get 527. Okay? Why don't you go ahead and try to figure out what you get when you decrease by 6% here and decrease by 3.5% there. That might be a little bit trickier, all right? So pause the video now and see what you get. All right, again, I'm going to keep going back to this. I'm decreasing 2250 by 6%. I've got 100% minus 6%. That's 94%. And therefore, I'm going to do 2250 times 0.94. All right, and you could imagine, right? Maybe I had something that would cost 2250, but I get 6% off of it. Let me just move that over there. I think I'm going to just clear this out. Let's do 2250 times 0.94. Yep, and that gives me 2115. All right, always the trickiest scenarios when you're dealing with percents that also have either fractions or decimals within them. Decrease 122 by 3.5%. Again, here's where it might be helpful to say, well, 100% minus 3.5% is equal to 96.5%, right? So that means I'm going to take my 122 and I'm going to multiply it by 0.965. Definitely don't want to do that in my head. 122 times 0.965. Just making sure that all looks good. 117.73. All right. We need to be good about being able to increase or decrease a quantity by a certain percent. Now, in all of these cases, right, we've been saying, oh, increase this, decrease that. But sometimes, right, you're just going to have to be able to figure it out. Now, here, I think it's pretty straightforward. Let's take a look at exercise number 7. The cost of gasoline has decreased recently by 4.5%. If it started at $3.80 per gallon, which of the following is its price after the decrease? All right, see if you can figure out what the price of the gasoline is per gallon after a decrease of 4.5%. All right, simple enough. Again, I can say, well, if I've got 100% minus 4.5%, that ends up being 95.5%. Use your calculator on that if you need to. So I'm going to take my $3.80. I'm going to multiply it by 0.955. I'm going to use my calculator now. 380 times 0.955. And I get 3.629, which is going to be 3.63. 363 per gallon. Okay, obviously you could actually have a price of gas like this. They oftentimes have a tenth of a penny on a gas thing, which is weird, but whatever. All right, let's take a look at one last problem. Or not. Nope, that's it. Sorry, my bad. I thought there was another problem. Apparently I was wrong. Right, what we talked about today, which is going to be important, critically important for what we do in the next lesson, is how we can increase or decrease a quantity simply with one multiplication problem. In every case, what we're going to do with increasing is multiply by 1 plus the decimal version of the percent, or 1 plus the percent divided by 100. In the case of decreasing, the great thing is we're going to multiply by 1 minus the percent divided by 100. And really what that's really giving us is multiplying by the decimal version of the percent that remains. So if I am going to decrease by 8%, the percent that remains is 92%, and so I multiply by 0.92. All right, this should be very, very easy, and hopefully it reminds you of work that you did in a previous class on this. All right, we're going to get lots of work with that as we move on. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.